This will be our geometry. We need to plot a pressure and velocity, so just take the Fluent from here, right click on the geometry, and just set analysis type as a 2D, because our geometry is 2D. So right click on the geometry, open the design modeler, right click on the XY plan and select the look at option. Now we draw the geometry. Just take a line. You can use the polyline. Okay, you just take a polyline and just draw the sketch. Click on the close end to close the geometry. Now we will adjust the dimensions. So go in the constraints and select the symmetry option. Now select the axis and just by pressing the control click all the points, so we can see here our geometry symmetry between that 2 points. Okay, now do same for 3. Okay, like this. So now we can see our geometry symmetry about the axis, like this. Now we will adjust the dimensions. Just select the length and distance, and first we uh, give dimension to throat. So like this, just select the points and give the dimension as mentioned in question as 10. Here also just take the length and distance and just give the dimension as per our geometry. So give the inlet as a 25. Outlet as a 35. Now select the inlet and outlet and just give the distance between them is 75, which is 75, right, as mentioned in the question. So we will write here 75. Okay, now we will maintain the distance of 50 of that divergence angle, right? So just select that line and give the dimensions. Just write the 50. So we can see that our geometry is ready. Okay, which mentioned in the question. Okay, now we will go for the surface. Before that, just verify the dimension once. All the dimension I took on in the meter, but in the question the dimension are meter in the mm, but now keep it as it is, no problem. Now we will create a surface over this sketch. Okay, select the geometry, press apply and press on the generate button. So we can see our surface is generated. Okay, now for the simplicity for mesh, we will go for the face split option. Like this, we will draw the 3 lines to do the better meshing. Okay, for that, select the XY plane, select the new sketch, and first draw the line at a throat like this, and just draw 2 parallel lines like this near the throat. Okay, make sure that your line is parallel to the line which we drawn at the throat. Okay, or you can maintain that line by go in the constraint. In the if you go in the constraint, so yes, here option is there. So just give the dimension between the, set the distance between 2 lines. Just click the throat and that parallel line and just write the 5. Okay, like this. Adjust the both the lines, just write the 5. Yes, like this. Now we do the face split. So for to do the face split, just go in the tools. Okay, first we can see here our this is on a whole geometry as a one face. Now we do the splitting. Okay, target face, select this whole geometry. In the tool geometry, select the 3 lines which we drawn in the new sketch. Okay, now press the generate button. Now we can see our geometry is splitted in parts like this. Now we can do the meshing process very easily by doing the face split. Okay, now close the geometry and open the mesh. Right click on the mesh and open. Now right click on the mesh, go in the methods and set as a quadrilateral shape of the mesh. Select the geometry, press apply. Select the geometry, press apply, and select the quadrilateral dominate. Okay, and select the all quad option. Okay, now press the generate and see the by default mesh. Okay, this is a default mesh. Now we will go for the edge sizing. Okay, just select the all the vertical edges like this. Right click on it, go in the insert, go in the sizing, and in the type select the number of divisions and just write the 30, and behavior you can set as a heart. Now press the generate button and see the by default mesh. Okay, now select all these lines, okay, which are walls. Just select the all lines, press apply, give number of division in the type, and just write the 20. Yes, and select behavior as hard and press the generate button. We can see our mesh is not well structured mesh. So to do the structured mesh, just select the face meshing. Right click. We need to we can solve this problem by option face meshing. Okay, so just right click on the mesh, go in the insert and select the face meshing. Okay, so just select all the face, press apply and maintain save as coordinator and press on the generate. So we can see, or we are getting very fine mesh, and at the throat region where the major gradient going to take place, we given very fine mesh. Okay, now we will go for the name selection. Name selection. Okay, so just select this line as a right click on it, and the name selection give the name inlet and this line as a outlet, and you can give a name to the wall, upper wall and the bottom wall. Okay, and don't forget to select the splitted lines. Okay, upper line or upper wall, or you can mention as the bottom wall. You can verify once. Okay, everything is okay, so go in the file and close the meshing. Now after closing the meshing, you need to right click on the mesh and press on the update button. So after pressing the update button, you will get the green tick here near the mesh. So after that, go in the setup and click on the edit. Set the number of processors based on your system. I'm going for double precision. Okay, this here we can see our mesh with the geometry, with the mesh. Now we will go for the density based solver, obviously, and go in the models, turn on the energy equation, and in the viscose I am going for the k omega SST. Press OK, and now we will going to set air as a ideal gas and the viscosity as a Sutherland. Viscosity will going to fall. Okay, now we will give a boundary conditions. So double click on the boundary conditions. Now click on the wall and press on the edit. Just check that it should be stationary and no slip, with no slip condition. Yes, press apply, close. Now go for the inlet and set inlet as a pressure inlet. Okay, because in the question mentioned that the total pressure is 3 bar. Okay, so in the gauge total pressure, just write that 3 E5 means 3 into 10 raised to 5, 3 E5. Okay, press the apply and take the temperature 202. Now in the outlet, just write the 0. Okay, no need to change anything, keep as this default outlet. Okay, just check the bottom wall also, sorry, upper wall also. Okay, like this. Now in the reference value we can check compute from the inlet, the values all is coming from the inlet. So temperature is okay, so sorry, we need to keep a temperature as it is. Okay, just write the 300 Kelvin. Okay, compute from inlet. Yes, now everything is okay. Or this will be our velocity. Okay, now go in the methods and set as all as a second order. And now we are going to measure the drag over the walls. So go in the monitors and select the option, the report files. Now click on the new, again new, and just go for the force report and click on the drag. Okay, I'm going for both the walls. Select the drag coefficient, or you can, if you want, you can go for the drag force. Just write the name, drag coefficient. Okay, just select everything to get the graph in the that display. Okay, our solution is not initialized yet, that's why the red color coming. Okay, now close and go for the initialization. Here we are going for the standard initialization, compute from the inlet and press the initialization. Okay, initialize. Now we can see our all the values are correct. Now go for the run calculation. Just give the 1000 up to 1000, maybe it will be converged, and press the calculate. Now we can see this is our CD plot. Okay, so we can see here our solution is converged now. Okay, our solution is converged now. Now we can see the contour from the graphics section. Double click on the contour and select all the these parts and click on the save and display, so we can see the contour. Now just deselect all and press on save and display, so we can see the contour. This is a pressure contour, and here you can maintain the color scale like this. You will get the number of layers of color. Okay, now you can change the parameter also. You can see the velocity contour. We can see the velocity is increasing. Okay, now change to Mach number. You can also see the Mach number contours like this. Now to plot the graph, go in the plots and click on the XY plot. So y-axis, in the y-axis you can see the pressure and static pressure is there. So we need to define the x-axis. So I am taking the wall. Okay, upper wall. So we can, if you, when you plot, click on the save or plot, you will get the graph like this. Okay, which is the static pressure distribution over a wall. Now to Now if you want to save this graph, so click here, one option camera is there, so click on that and you can select the format. I am selecting JPG. Just save at your location wherever you want to save. Okay, so I am looking for the desktop. Okay, I will save on the desktop. So just type any name now. So here we can see our graph. Okay, you can export also like this, or you can also see the velocity distribution. So sorry, you need to go for the Mach number distribution. So we can see Mach number is increasing with the axial distance like this. Like this you can plot and export the graph, and this is the value of drag coefficient. Okay, now close. Right click on the result and press on the edit. Just select the streamline and select the surface streamline because our geometry is 2D. In the surface just select the symmetry one. Okay, no we not need to select the inlet. Yes, now we can see here these are the streamlines. You can animate also these lines. Okay, to animate these lines go in the animation section in the here and just select the streamline and press the play button. Okay, so we will decrease the speed to visualize better. Okay, now press on the play button so we can see our beautiful simulation. Okay, like this you can do the animation. So thank you for watching, guys. If you like this video, so just press on the like button and subscribe to my channel. And if you want to do any training or internship, so you can mail us also. And here through contour option you can see the contour with the better quality of the image. Okay, you can change the number of color layer also. Thank you for watching, guys.